You're welcome to my YouTube channel. This is your teacher again, Science Bro, the one you have been waiting for. It's quite a while since I last posted a video. Now today I've started posting for you videos again. Today I've brought for you a video on what we call chemical bonding. Now before I start explaining this chemical bonding, I request kindly subscribe to my YouTube channel. Just hit the subscribe button below this video. This will help me to push on and make for you more interesting videos. Remember, I'm breaking this chemistry in a very simple way. Now, for your case, you'll get notifications of such videos. Let's now start our topic, what we are discussing today, as chemical bonding. Now, under this topic, I've brought for you several subtopics. The first subtopic is a bond and bonding. So I'm going to talk about what's a bond and what's bonding. Actually, they are the same words. Now, bond and bonding. Number 2, I'm going to talk about why do atoms engage in bonding? Why do atoms bond? Number 3, I'll look at the types of bonding. Strictly, I'll look at only 3 types of bonding. Remember, there are a number of types of bondings, more than 3. But for the scope of our level and this lesson, we shall only dwell on the 3 types of bonding, which are the major types of bonding. The other ones are also important, but outside our scope. Now, the 3 types of bonding, one is called ionic bonding. Ionic bonding, as the term says, it results in formation of what we call ionic compounds, or compounds formed when ions combine together through a certain force called ionic bonding. Ionic bonding will also be called electrovalent bonding. Number 2, we shall look at what we call covalent bonding. Covalent bonding is also called molecular bonding. Rather, the bonding that results in formation of covalent compounds or results in formation of what we call molecules. Then we shall look at the third type of bonding called metallic bonding. The bonding that results into the structure of a metal. So here there is no combination of different atoms, but rather the bonding occurs within a single element called a metal. Now let's look at the last subtopic will be effects of different types of bonding on the formed compounds. Remember, ionic bonding results in formation of ionic compounds. Covalent bonding results in formation of covalent compounds, or what we call molecular compounds. Then metallic bonding is actually resulting into a metal structure. The metal structure, in other words, we can say a metal lattice, or the lattice structure of a metal. Let us start right away on the first subtopic. The first subtopic is a bond and bonding. So a bond and bonding. I have not written notes on the blackboard here, but as I talk the notes, you'll be able to write the notes. So what is a bond? Now, a bond only is important as long as chemical reactions are taking place. Remember, a chemical reaction takes place when 2 or more elements come together. Now, a bond is a force of attraction between 2 or more ions, atoms, or molecules. So, a bond will exist when 2 or more things react together to form what we call a new substance. The new substance is being called a compound or a molecule. Now, a bond is a force of attraction between atoms, ions, or molecules. So ions can come together and combine. Atoms can come together and combine. Molecules can come together and combine. Even elements can come together and have a bonding within them, their own structure, and that will refer to a metal. Now that is a bond. So bonding is the attraction that exists between 2 or more atoms, ions, or molecules in forming a compound. Let us look at why do atoms bond. So next subtopic is why do atoms bond or engage in bonding. Now we have said that bonding is important because in chemistry we have what we call chemical reactions. Now to understand why atoms bond, we need to understand the electronic structures of different atoms as they combine to form compounds. Let's take an example. In a reaction between sodium and chlorine to form sodium chloride. So let's look at that example. In a reaction between sodium plus chlorine to form sodium chloride. What is actually going to take place here is that this element called sodium has to combine with another element called chlorine under suitable conditions such as heat to form sodium chloride. Remember, this is only possible as long as sodium has a love to combine with chlorine because it lacks something. Sodium lacks something, chlorine lacks something. That's why they are getting together to form a compound called sodium chloride. So let's look at the electronic structure of sodium. Sodium here has atomic number 11. So it will have the electronic structure like this. So first shell has 2 electrons. Second shell has 8. Third shell has 1 electron. So chlorine here, first shell has 2, of course. Chlorine here is 17 atomic number. So it has 2, the first shell. Second shell has 8. Third shell has 7 electrons. Now we realize that atoms are only stable if the outermost shell has 8 electrons in case the atom has atomic number more than 2. But if the element has atomic number of 2 and below, it is stable if the outermost shell has the 2 electrons. So these have many electrons. So to be stable, sodium has to have 8 out, but it has 1 electron. The electron outside is called a valence electron. Chlorine has 7 electrons, so it's not also stable. That's why they are going to combine. In combining, they will gain stability. So the reason why atoms bond is because they want to attain a stable electronic structure. Sodium wants to have 8 electrons out. Chlorine wants to have 8 electrons out. That's not possible if the element is alone, except in metals where you shall see metallic bonding. But when they form sodium chloride, both sodium and chlorine will have been stable. So the reason why atoms combine or bond is to attain a stable electronic configuration having either 8 electrons in case the electrons are many, or 2 electrons if the electron number is from 2 and below. That electronic configuration is similar to the electronic configuration of noble gases or group O elements, or group 0 elements, group 8 elements. That's why they combine. Now, let us dive into the types of bonding to explain how sodium chloride will be formed in the process after the reaction has taken place. So, we are looking at next thing, the types of bonding. Now, we said there are 3 types of bonding that we are going to talk about. Let's start with the first one, ionic bonding or electrovalent bonding. So, in ionic bonding, we normally form what we call ions. So, ions are only formed when either there is loss or gain of electrons. So what's ionic bonding? Ionic bonding is the type of bonding that occurs between a metal atom and a non-metal atom through transfer of electrons from a metal atom to a non-metal atom. So indeed, metal atoms have fewer electrons in the outermost shell. They have about 1 to 3, the metal atoms. The non-metal atoms have about 5 to 8 electrons in the outermost shell. That's why in this case, there is a case where a metal atom has to lose electrons because it has fewer, then a non-metal atom has to gain electrons because it has many. Just a review of your periodic table here to make you grasp it well. Group 1 elements, this group, and this group normally consists of metal atoms. Then from group 5 to group 8, they consist of non-metal atoms. Group 4 is a mixture of metal atoms and non-metal atoms. So these are called the metal atoms. Up to group 3, they have 3 electrons in the outermost shell. Then the non-metal atoms have about 5 electrons in the outermost shell. Let's look at, for example, formation of sodium chloride in explaining this type of bonding. Formation of sodium chloride. I'll look at 2 examples. We say sodium chloride is only formed in a chemical reaction between sodium metal and chlorine gas. Now, we are not going to show the equations because we are not interested in the equations, but rather we are interested in what actually takes place. So this is what actually could be the equation. That sodium combines chlorine gas from sodium chloride. But in this combination, this chlorine has to first become 2 chlorine atoms, chlorine and another chlorine, then they can't come together with sodium. So that's how a chemical reaction takes place. So in forming sodium chloride, let's put here our sodium atom. Sodium atom. Remember, sodium has atomic number 11, so it has something to do with 2 to 8 to 1. So we are only going to use the outermost shell, which has 1 electron, to save space and also to have simple explanations. So sodium will come together and combine with chlorine. Chlorine here has 2 to 8 to 7, so it has 7 electrons in the outermost shell. So we can represent this one with X, can use dots, or we can use crosses, or we can put the electron itself. So since this bonding is involving transfer of electron to gain stability, sodium will lose 1 electron. Metals, because of having few electrons, from 1 to 3, they will have to lose that electron. So you'll give this electron to that. So by transferring 1 electron from sodium to chlorine, chlorine gains 8. So this is what becomes of the structure. Remember, sodium has 8. Sodium here will have lost 1, we make it an ion. The electronic configuration will be 2 to 8. That means the outermost shell will actually have 8. We've not shown it here, but remember the next shell inside has 8, which we are showing here with this configuration. Then this will have changed into what we call a positive ion. Then it will be in contact with chlorine, which has 8 electrons now in the outermost shell. So this has become an ion, chlorine ion, or we call it in a better language, chloride ion. So this case here, these 2 ions combine electrostatically. That means like and opposite charges attract. Now when we see sodium nearer the chloride, they will attract, form our compound that we are calling sodium chloride somewhere here. that we are calling sodium chloride. That's how we form sodium chloride in a chemical reaction between sodium and chlorine. Let's look at another example here. Maybe formation of magnesium oxide. So magnesium oxide is formed in the reaction between magnesium and oxygen. So magnesium has atomic number 12, so it has electronic configuration 2 to 8 to 2. Then oxygen has atomic number 8, has configuration 2 to 6. We realize that oxygen needs 2 electrons to be stable. Magnesium is going to lose 2 so that its outermost electron configuration will actually have 8. Let's dive into that. So this is magnesium with 2 electrons in the outermost shell, just putting them a bit nearer. Yeah. Then it's going to combine with this oxygen, which has 6 electrons in the outermost shell. Let's use a cross here. So this is the oxygen. So in the combination process, in a chemical reaction, when magnesium bonds in oxygen, you form magnesium oxide. So magnesium is we are going to transfer the electrons of magnesium, both of them in the outermost shell. Remember, the immediate shell here will have 8 electrons, which are these 8 here. So when we form this, we shall now have magnesium ion here. Then here we shall have the chloride ion, the oxide ion, which has gained 2 electrons. When an atom loses electrons, we give it a positive charge. When it gains electrons, we give it a negative charge. So here we shall have our magnesium, 8 electrons. So it has configuration 2 to 8. This has configuration 2 to 8. So it has 8 here. These 8 are in the second last shell. Then these 8 are for this last shell in here. So here we have transferred 8. So we have this as the oxide ion. Then this is the magnesium ion. So they will finally form for us magnesium ion being attracted to the oxide ion, forming magnesium oxide. Forming magnesium oxide here. Hope we get that right. Then the oxide ion here. So this is the formula of magnesium oxide. This is magnesium. This is oxygen. That's how ionic bonding happens. So ionic bonding results in formation of what we call ionic compounds. So magnesium oxide is an ionic compound. Sodium chloride is an ionic compound. Just combine metal and metal, you form ionic compounds. Ionic compounds have different characteristics. Number 1, characteristics of ionic compounds. The first one, they are normally solids at room temperature. We have them as solids. We have a number of them in the laboratory. Like here, I have aluminum chloride, which is a solid substance. Then number 2, they are normally having high melting and boiling points. If you heat your table salt at home, it will take longer to melt. They are normally soluble in water or soluble in solvents that we call polar solvents. Solvents that are polar are solvents such as water, which are normally charged solvents. They have charges in their molecules. That's why we call them polar solvents. Then they are not soluble in nonpolar solvents. Nonpolar solvents are those whose molecules are not charged. So they can't permit dissolving a charged substance, which is an ionic substance. And most of these nonpolar solvents are organic substances such as alkanes, hexane, etc. Now, they are soluble in polar solvents like water. They conduct electricity in either molten state or aqueous state because they possess ions. Let's dive into the other type of bonding called covalent bonding or molecular bonding. molecular bonding. Now, covalent bonding results in formation of what we call covalent compounds, and it's a bonding that occurs between two or more nonmetal atoms. Strictly, they must be nonmetal atoms. Now, what is this type of bonding? Covalent bonding is the type of bonding that occurs between, or a force of attraction between, two or more nonmetal atoms as a result of sharing one or more electron pairs. As a result of sharing one or more electron pairs. So every covalent bond is formed as a result of two electrons between two atoms. Now that's what we call one electron pair. There can be more than two electrons in a covalent bonding situation. Can be three electrons, can be three electron pairs, those are 6 electrons. Now every covalent bond we represent it by a line. A line represents 2 electrons. 2 lines will represent 4 electrons. 3 lines will represent 6 electrons, which is a triple bond. Let's look at examples here, how we form what we call a covalent bond. I'll look at chlorine molecule, look at oxygen molecule, look at nitrogen molecule a bit faster so that we save time here. Now let's look at how an oxygen molecule is formed. A molecule consists of 2 or more atoms, which 2 or more atoms bonded together to each other. So like oxygen molecule is a diatomic molecule having 2 oxygen atoms which have covalently bonded to each other. Let's look at, first of all, look at the chlorine molecule first, Cl2. So here we need 2 chlorine atoms in the bonding situation. Chlorine is 17, then another chlorine is 17. So I have this chlorine, let's use only the outermost electrons. This has 17 electrons. In total, it has 7 out with a configuration of 2 to 8 to 7. This also has 7 electrons in the outermost shell. So chlorine, chlorine. Now when they come together, this type of bonding is as a result of sharing electrons. Now, an atom coming into bonding wants to gain stability. This has 7 electrons, wants 1 electron. This has 7 electrons, wants 1 electron. Now, atoms will share what they lack. If you lack 1 electron, you will bring 1 in the sharing pair. If you lack 1 electron, you will bring 1. If you lack a 2, you will bring 2 in the sharing pair. So look at the magic. Now, this will bring 1, this will bring 1, then they will form what we call a covalent bond. So we see that you can either overlap orbitals or rather just put them, they touch their shells like that. But here I'm overlapping. So we are going to have these 2 here first. Then each will bring 1, 1 because each lacks 1. So in bringing that pair, if you showed by this structure, you do have such an arrangement, which is this. So you'll have this. Now, if you counted for each atom, it has 8. This chlorine, 1, 2, 3, 4, 5, 6, 7, 8. This chlorine, 1, 2, 3, 4, 5, 6, 7, 8. Each has become stable in sharing the electron pair. So you'll have 1 bond formed, which results into what we call Cl2. That means this every 2 electrons is 1 covalent bond, which is this line here, which is now this molecule. Let's look at another example, such as formation of oxygen molecule. So in oxygen molecule, oxygen has atomic number 8. So it has configured every oxygen. Since there are 2 oxygens coming into bonding, you have this oxygen have a configuration 2 to 6 every atom. So I'll have 1 atom here having 6 electrons out. So I put 6 there. Oxygen. It's going to combine with another oxygen. Now, since this lacks 2, it is going to share 2 in the contribution. So this will also contribute to form covalent bonds. So do like this, do like that. So this will bring 2. Let's first put its electrons here. So it has brought 2. This also brings 2 in the sharing pair. Then I have oxygen and oxygen. So I have that. And finally, you see there are 4 electrons. This 2 is 1 bond. This 2 is 1 bond. So finally, you have something like this. That's what we call oxygen molecule. It has 2 bonds in between 2 oxygen atoms. Of course, when you write like this, you cannot see the bonds, but when you show the bonding, you can now see the bonding. So you can try out for nitrogen in your free time. Nitrogen molecule. So here there is sharing of electrons and forming a bond. So you can try out for nitrogen molecule, you can try out for methane. Maybe let's think about methane and see how the bond is formed. So covalent bond can occur between similar atoms or different atoms. Here there is carbon atom with 6 as atomic number, electronic configuration 2 to 4. Then I have hydrogen, but there are 4 of them, but each has atomic number 1, so electronic configuration is 1. So carbon here has 4 electrons out. It's going to combine with hydrogen, which has only 1 electron out. So, and here we are using about 4 hydrogen atoms. So they are all going to bond here. So since it lacks 4, it will bring 4 in the sharing pair, but now it will need 4 different atoms since each atom brings only 1. So I'll have this, such a structure. So I'll have here carbon. Hydrogen brought 1, carbon has brought that. Hydrogen brought 1, carbon. Hydrogen brought 1, carbon. So I have hydrogen, hydrogen, hydrogen. Finally, I'll have carbon with 4 different covalent bonds, because each bond is actually, each 2 electrons is 1 bond. So this is what we call the methane molecule formed as a result of covalent bonding. Let's now dive into metallic bonding. But before you look at metallic bonding, we've said that every compound formed as a result of covalent bonding is actually called a molecular compound or covalent compound. Now we have seen that some covalent compounds here are gases. Now, characteristics of covalent compounds: number 1, they exist as gases or liquids. Water is a liquid because it is having nonmetals, oxygen and hydrogen. Then we have oxygen gas is a gas. Methane is also a gas. We have covalent compounds are majorly gases or liquids, but some few are solids. Now they have low melting and boiling points. They normally don't conduct electricity in their molecular form. Then they are, of course, those are the 3 major properties. Do not conduct electricity because they consist of molecules but not ions. Have low melting and boiling point. They are also characterized by being liquids and gases majorly, though few are solids. Let's look at metallic bonding. Metallic bonding. So in forming, you see, every type of bonding occurs as a result of a chemical reaction. Even this covalent bonding that we've just talked about, like when you react hydrogen with chlorine to form hydrogen chloride, these are 2 nonmetals reacting to form a molecular compound or a covalent compound. So you can have several examples of those covalent compounds: hydrogen chloride, water, carbon dioxide, nitrogen, methane, sulfur dioxide, as long as you have nonmetals in the structure only. So let's look at the last type of bonding called metallic bonding. So a metallic bonding is the type of bonding that exists within the structure of a metal, where there is attraction between positive metal ions and delocalize electrons. So here the metallic bond is just a force between created positive ions and electrons. Now a metal, when it is in the laboratory, such as sodium metal, lead metal, it can exist in the laboratory in a stable form because it stabilizes itself inside there by gaining the stable electron configuration having 8 electrons. Let's look at that type of bonding with an example. Let's take an example of sodium metal. Sodium metal is actually stable unless you bring something very reactive and you supply suitable condition, then it will undergo ionic bonding through forming sodium chloride, maybe with chlorine. But in this case, if it's alone, it can stabilize itself through what we call metallic bonding. So how does it stabilize itself? Sodium has atomic number 11, so it is 2 to 8 to 1. We realize that in this case, sodium is not stable, but it can be stable by losing this one electron, but does not lose to anything else because there is no substance to react with it. Otherwise, sometimes some of these metals are so reactive that they are attacked by oxygen. That's why we keep sodium in oil, to prevent it from a reaction, because it's very reactive. Otherwise, they can stay dormant like in oil where there are no conditions. Other metals can stay dormant without any effect of atmospheric air. Now, how does sodium metal stabilize itself despite without reacting with anything? It has to lose this one electron. Where does it go? Within the metal structure, the metal atom called sodium will lose one electron. So it will become sodium ion with its electron nearer there. You see, when we talk about a metal structure, it has millions of atoms. We are not talking about one atom. Every element you see are actually millions of atoms in a single metal structure that we are talking about. So sodium metal will have millions of sodium ions and electrons around it. Now these electrons are not limited to being around the metal ion. They are actually moving freely throughout the whole structure. So there is a force of attraction between these electrons as they move freely in the metal structure. As they move freely in the metal structure, there is a force of attraction between the metal ions and the electron. So a metallic bond is a bond that exists between the bond that is as a result of the attraction, or a metallic bond is a force of attraction between the positive metal ions and the delocalized electrons that are existing in the metal lattice. So we've seen why this type of bonding occurs is also gain stability. Generally, we can just illustrate that structure having positive ions and negative ions, smaller positive ions, negative ions, smaller like that. Negative and positive, negative, positive, negative, positive, negative. Positive ions, negative, positive ions, negative. Like that. So the bonding will just be forces are existing like that in the metal structure to extending throughout a longer distance or throughout so many atoms that we might not be able to illustrate here. That we might not be able to illustrate here. So that is what we call metallic bonding. So metallic metals have, all metals have this type of bonding. Some metals can lose more electrons. If the outermost are 3, like in aluminum, it will have to have so many electrons compared to sodium. That's why some metals are weak, can be cut by knife such as sodium, but you can't cut magnesium or aluminum. This is because like sodium contributes 1 electron, so the force created inside there will be weaker than the force in a metal that loses 2 electrons in its metal lattice, that loses 3 electrons in the metal lattice. Let's look at the last subtopic here called effect of bonding on the properties of these compounds here. So effect of bonding, different types of bonding. So bonding on properties of substances. On properties of substances. So we can have here the property Then the type of substance, we have ionic compounds due to ionic bonding. Then we have covalent compounds, covalent compound. Then we have the metallic compound, a metallic element or substance, metallic substance. This is not a compound because it's a single element. So there are several physical properties here. The first property, we can look at the physical appearance, physical state. Can also look at solubility in solvents, Then also look at what we call melting stroke boiling points, melting and boiling points. Then lastly, we look at conductivity, electrical conductivity. We shall not look at thermal conductivity. It's not very important to us here. So what's actually now physical appearance? Ionic compounds are normally crystalline in nature. So they appear as crystalline in different colors. They can be blue, red, it's several other colors, blue, green, like that. Covalent compounds are normally just appearing as liquids with different colors, liquids or gases, or solids even with different colors. They can be yellow. Also, they have various colors. Metals are actually appearing as shiny substances with different colors also. Now, we have several metals on Earth. You have some metals that are gray, some metals like copper is brown. You have lead, zinc, iron, which are gray. So metals have also different colors, but most metals have similar colors. Now, but they have various colors within the metals. So physical state, ionic compounds are normally solids at room temperature. Covalent compounds are liquids, gases, or solids. Liquids, gases, solid. Then metals are basically solids at room temperature. So solubility in solvents, ionic compounds are soluble in polar solvents. Soluble in polar solvents like water. We said polar solvents are solvents whose molecules have charged particles, whose molecules have charges, opposite charge, positive and negative charges. Like water molecule is charged, so it can dissolve an ionic compound because an ionic compound consists of ions. Then we have covalent compounds. They are soluble in nonpolar solvents, solvents which have no charged molecules. Soluble in nonpolar solvents. And basically, these solvents are organic solvents such as benzene, methylbenzene, alcohols, all those benzene, methylbenzene, alkanes, not alcohols. Alcohols lie under polar solvents, but that we can explain it later in other videos. So metals are insoluble actually in water, in solvents. Melting and boiling points, ionic compounds very high, covalent compounds low, because they are normally gases or liquids. This one's high. Then we have what we call electrical conductivity. Ionic compounds conduct electricity in two forms. They cannot conduct in solid form. You have to either dissolve in water or apply heat to melt. Then covalent compounds, for them, they do not conduct electricity because they consist of normally molecules, only not ions. Though there are a few exceptions. Metals conduct electricity in solid form, in liquid form. Whether you melt it or you don't melt it, it can conduct electricity because it uses electrons to conduct electricity. Now I've come a long way. I discussed what's a bond, a force of attraction. I discussed why atoms bond so as to gain a stable electron configuration similar to that of noble gases. I discussed three types of bonding called ionic bonding, bonding between a non-metal and a metal to form what we call ionic compounds through electrostatic forces between positive ions and negative ions. I looked at what we call covalent bonding, bonding between nonmetal atoms, resulting in formation of molecules through sharing of electrons between atoms. Then I've looked at metallic bonding, which is the bonding within the internal structure of a metal as a force between positive metal ions and the negative electrons. Then we looked at different properties, physical properties that compounds have as a result of the bonding in them. We looked at solubility, physical appearance, melting and boiling points. We also looked at physical state of the substances. Now, I would like to thank you very, very much. Please subscribe if you're a first viewer. We meet in the next video. Bye. What the